Hello there, and welcome back to another day where you have some free time. And in this day's video of unstd-c, we will be adding more overhead to our malloc and free functions as we try to merge, trim, and sort out the free sections of a memory chunk. So let us get started. Well, though before that, I did change a few headers, like standard arg. I've made it so that the built-in VA list will be type def into the new CVA list, and that will be type def into the VA list that we know, and I guess sys types as well, where I added more of the Linux headers, where this contains the types that are used in syscalls. So that is all from that. So now let us get started in malloc.c. And I see here that the trimming function is not really complete here. And the way we find the free chunk is something that I do not really like. So let us open free.c as well and the malloc internal. So first of all, I want the freed pointer removed from heap data, since we will just be traversing the heap data by the data from heap chunk. And when the data in heap chunk does not match from the previous one nor the next one, then there is something wrong with the heap data. It has been overwritten maybe. So we'll create a few functions for that. First, we create a macro. So let's say is the pointer that we have is in heap, where p is the pointer we provide and d is the heap data. And yes, we cast this both into a character pointer, and the pointer should be greater than the d pointer, and p should be less than d when its original size is added back to it. So we make sure that the pointer is not out of bounds from the heap data we've mapped, or else we're gonna get a seg fault when we try to treat it as a heap chunk. Now, for the next function, I guess it will return a heap chunk, and it will try to find the next chunk from the heap data. And we take as well the heap chunk that we want to find the chunk after it. So C. And if that is null, then we just return the very first chunk after the heap data. And then we may as well move the mmap function to another function that will return heap data. So maybe we can call that new heap, where it will just take a target size, a size t, and the very last chunk before our new chunk. So we take that to complete our linked list. And then I guess the functions, new chunk, next chunk, we can also check if the next chunk returned is free or not in malloc itself, so that is fine. I guess we can also do a previous chunk. And this will both return null if the pointer in heap macro returns false. Well, at least that is the plan anyway. So let us create these three functions first. So we can edit src, standard lib, malloc, and malloc internal c. So we create a new source file, and we can include malloc internal, oops, .h. Since we do not have an LSP, we kind of just do it bare bones. I don't really know if it will make me a better programmer, but oh well, at least we tried. So where are we? I'll copy this mmap function. Well, we can remove it entirely and move that here, align it with the tab, and D over here can be a new heap data type. And this should be aligned this way. And if this is map failed, then instead of go to return, so we have no go tos here. So we'll just return null entirely. And instead of 4096, we make this the target size over here as well. And here as well in mmap. So target size. And then the other setup that we did in malloc, here in the next one, the previous one, and if libc memory is null, that will be taken care of as well in here. We may as well align it. So I should not forget to actually return this heap data that we've mmap, since if I forget now, I'll be debugging this for 3 hours later. And I believe that is done. And instead of this shenanigans of an if else, why can't we just make this a variable size t? And this is the target size. So over there, and we make this a ternary operator, where if this is true, then the target size is just 4096. And the size of the heap data header is already taken care of in new heap, so that is fine. But if this is false, then we add the size plus the size of the heap chunk type. Well, now that I think about this, this is maybe more readable in a macro. So let's go to malloc internal h. We define more macros. So heap data size is just a size of pointer. So to extract heap data, I'm not sure if we've saved any characters, but it is a bit more understandable this way. And I guess heap chunk size as well. Might as well make this align, since Vim has sort of good autocomplete without any plugins. So this will be the heap chunk data, no, heap chunk type. And this definitely saves some characters. Now, let's go back here. And this will be the heap chunk size. And this will be the heap data size. And heap chunk size for here as well. Now we can check if the new heap allocation to D with our target size and our last heap data, if we found nothing, if this is null, then we return null. And then, considering that we've removed the freed section from heap data, and this will be gone now. Let's go back to malloc internal, C. So the freed section is removed. So we may as well just create a new struct, heap chunk types, T, I guess, for temp. And this will be this freed status. All right. I actually did not add any status yet, if it's freed or not. So that will be essential to our later plans. So we can just include standard bool over here. Since if I just make this ones and zeros, I may mix it up sometimes and add more time to debugging later. So the boolean, I guess freed is fine. So the freed status of this temp variable will be true. We may as well explicitly include standard bool over here. And what else am I missing? I guess the size of this first chunk that we've created. So size, we can make this the target size minus the heap chunk size for the headers, and n equals to size of that is related to the heap will be replaced by this macro, and over here as well, heap data size. So we've done that. We also have the previous size, but since this is the first chunk in the data, that should be 0. Now for the way we will find the free chunk, well, we need to have next chunk possible first. So of course, if D, its size is 0, no, if D is null, then we can just return null, just in case that I mess up. Though, if we don't, then maybe we can remove that condition. For now, we'll do it that way. Now for the next one, we'll calculate it the usual way by casting C into a character pointer plus adding its size plus the heap chunk size. Now the return value of this is based on next being still in the heap data. So there's that. And if that is true, then we return next, else we return null. Also, I guess while we're running next and previous, I guess we can also check if the previous size of next is equal to the size of the current chunk. Though that only is, well, that only, I could only do that if this macro returns true. So I guess there's no need to do that yet. Now, for the previous chunk, there are now two conditions here. If D is null and the previous size of C is equal to 0, then there is no previous chunk in the seed data. Else, we do almost the same thing here, but instead of calling it next, we call it previous. And instead of adding size, we subtract it, more specifically, previous size, and we subtract heap chunk size as well to that. Also, this should be previous now, and this one as well. So that is the new additions over here. And we're already at 16 minutes, so gotta make this fast at malloc, where we try to find the next chunk for now, since that is guaranteed to be freed. So next chunk, D and null. But in the next video, we will be implementing the way we actually need to find the free chunk using next chunk. Or maybe I can make that into a function. Yeah, maybe it's better to make that as a function. But that is it for now. And may I see you on the next one.